Hey there and welcome to another channel video. Today we have another tooltop collaboration, but from their WinAPEX sub-brand. What I have here for you is the WinAPEX clamp meter with leakage detection. Other from the clamp, we have also multimeter functions like resistance, capacitance, temperature measurement, among others. When they asked me if I want to review it, they mention, and I quote, its biggest features is high precision current measurement. It can measure leakage current, which is not possible with ordinary clamp multimeters. So let's try to see how precise it is and check that leakage current measurement. As always, and for disclosure, this device was sent to me free of charge for this review, but I didn't receive any payment for making this review from tooltop or WinAPEX. Even so, I would like to thank tooltop or WinAPEX for their collaboration with the channel, but not only. I would also like to thank you for the sponsoring this channel by using the affiliate access links on the screen or in the description before doing your purchases on AliExpress or Amazon. Same price to you, but a big help for the channel. Thank you. Enough chit chat, let the tests begin. Let's see how this is delivered. It comes in this retail box without any indication of the manufacturer. So let's start by opening it. We have a cool bag and an instruction manual. Let's take this out. The instruction manual is printed on black and white. No special colors or anything. It seems to be more or less well organized. Yeah. A lot of information here. So yeah, okay. So let's see what's inside. Okay, first of all, we have the unit. I will see this in a bit. Let's see what else it is delivered. We have a temperature probe delivered, usual USB Type-C to Type-A charging cable, and a set of probes also. Okay, let's open it. So this is plastic. It's not the most flexible one I had here. Yeah, but it's plastic. We have a very nice and sharp probe. This will not go out. Yeah, a set of probes with a nice sharp end. This is just a cap. You may cut it if you want to have a protected version of it, but the tip will not pass through the end of the cap. So yeah. Okay, left angle connectors, and let's see what we have in here. Let me open this. Okay. This is a small clamp, all plastic, as it should be expected. It seems to have a flashlight in here, yeah. Okay. It has a good aperture, but I will measure this. And yeah, it seems only 4 buttons, 5 buttons, and this should be the connector for the power. Since this is battery operated, it doesn't require batteries, AA batteries or AAA. So yeah, it's small, but it fits very well in your hand. Okay, let's power this on and see how it works. So in terms of operation, it's very easy to use, very simple. You have those 4 buttons in the front, and you have an extra one here in the side. So connection for the probes in the end, and that's it. Okay, let's start by pressing the power button. This is the smart mode, where when you are with these 4 points in the screen, it's the smart modes, where you will be able to detect among several measurements like voltage and resistance and so on. You can use also the select button to control different modes. For example, once it will come to DC voltage measurement with 3 decimal digits. Twice it will come to AC voltage, also with 3 decimal digits. You have measurements for ohms, so resistance, also diodes and continuity. You have measurement for capacitance and for frequency also. And finally, you have the temperature measurement. Once it will say the temperature in Celsius degrees, and if you press again, you will have the temperature in Fahrenheit degrees. Okay, so the second button, if you press it while reading a measurement in the screen, it will activate the hold. It will keep you the reading on the screen freezed. But if you press it long enough, it will give a beep, and now you are able to change between 5, I think, yeah, you have 5 degrees of light in this, and you can press it again and it's on hold. You have to press it for like 3 to 5 seconds. So the third button is the NCV AF. This is the near contact voltage detector. And you have also the live, when connected a probe in this socket, in the live socket, it will show you if the line is live or not. And finally, you have also the backlight button. If you press it for a bit, like this, you have a light for illuminating what you are doing. Press it again for a while, and it's off. So you have also the zero function. For that, let me show you how to use this button. This button is for current, so all other measurements are done here. The measurements with the clamp are done selecting this button. So let's try it. Right now we have AC current measurement in milliamps. If you press again, you will have it with 3 decimal digits in DC amps, and right now you can press the 0, as you can see, to 0 the measurement. You can press several times until you have a 0 position, like this. It's always variating, but yeah, this is 0. Now it's ready for measurement, and you can press again here a second time to have also DC, but with larger digits on the left. So it will have less on the right. Again, 0 for putting the measurement at 0. That's it in terms of operation. The clamp has an opening about 2.6 millimeters, more or less, something like that. Maybe 2.8 even. And for my American friends, that should be about an inch, yeah. So it's good enough for most of the requirements. Okay, and that's it in terms of operation. Now it's the time to talk about this video sponsor, PCBWay. I always use PCBWay for creating my boards with a professional factory quality, as you saw in my millivolt voltage reference board. It is very cheap to manufacture your PCBs on PCBWay. You can manufacture 10 PCBs for only $5. How awesome is this? And it is pretty easy also. Just insert here the PCB dimensions and you'll have an instant code. So when you want a PCB, visit PCBWay to get your code, and if it is your first time ordering from PCBWay, you can use our access link for a $5 credit. And don't forget, they also have component assembly service, 3D printing service, and much more. For voltage measurement, I brought my DC voltage calibrator down, and also my STM3045X multimeter from Sealant is here. Let's test the WinAPEX 268B, and let's start now. So we have 1 volt. WinAPEX is a bit higher. This one, if you round it to 3 decimal places, is spot on. 2 volts again, 3 volts, 4 volts, 5 volts, 6 volts, 7 volts, 8 volts, and 9 volts, and back to 0. Okay, so let's decrease the range. Right now we are in millivolts. So 100 millivolts, 200, 300. It seems to be spot on. 400, 500, 600, little difference. 700, 800, 900, and my Siglant is always spot on also, and back to 0. Let's move on to 10 millivolts. 10 millivolts in the 268p, 10.2 in my Siglant. Okay, 20 millivolts, 30, 40, 50, 60 millivolts, spot on, 70, 80, 90, and back to 0 again. Let's go a notch down again. So this is 1 millivolt, and it's not able to detect in the 268p. 2 millivolts, 3 millivolts. Okay, from the one he is able to detect. Okay, 5 millivolts, it seems good. 7, 8, 9, and back to 0. Let's try again 1. Give it time. No, it will not get there. Okay, so that's it in terms of DC voltage. Let's now check the AC voltage measurement. This should be around 233 to 240 here in my zone. Let me first put the neutral in, and now, yeah, 238. It's the normal here in my zone. Okay, very nice. So let's move on and see how the EV this is the NCV function of the device. So it should detect by proximity electricity. Let's see how it works. Okay. It seems to detect very well. Look at this. Okay, pretty awesome. You can detect also in the socket. And I can tell you right now that the live wire is on this side. Okay. So this works pretty well. Just missing the live function. Let's press again this and see the live function. So for the live function, let's first start with this socket. This should be the neutral. Yeah, no signal here. And the second one, yeah, we have obviously the live. The beep is very loud, so it's very good. And yeah, that's it. So for the clamp measurements, what I will do is, right now I have my DC power supply configured. It's outputting 5 volts to a maximum of 3 amps. I have also my DC electronic loads also programmed for some charge. So let's put this at 0. The manufacturer says that you press several times until you get 0. Okay, and for checking, I have here my GD166B, I think, from GDVDA. I already reset the device, so let's put it here just to confirm the readings. Okay, we are set. Okay, so powering up the DC load. Right now I have 500 milliamps in load, 0.5 amps. Okay, it seems to be reading more or less the same values. I think this one is having a bit more interference. Let's move it to here. Okay, so let's move this to 1 amp. Okay, it seems to be close one from the other. Yeah, 1.054, 2 amps. Again, we have here some differences, but nothing that is really serious. Again, 3 amps. Okay, 3.12 in the GVDA and 3.18 in this one. Let me check again to make sure we are 0. Yeah, and let's try again. 3.200. Yeah, it seems to be even higher. Yeah, so for 3 amps we have a little difference. Let me just reset this also to 0 again. Yeah. Yeah, they seem to have a little difference. Again to 1 amp. They are more closed in this low amperage. Okay, that's it in terms of DC. To test the AC current metering, I have here the clamp already zeroed. Let's connect to this wire like this. It has already some readings, and you can see it also on the GVDA that it also shows some readings, so let's leave it for now. I brought my own power supply that is connected also to the DC electronic load, and I have this power extension cable that I removed the protective plastic, so it's naked right now, and I will be metering the consumption of electrical energy while increasing the amperage up to 5 amps. So let's start with 1 amp. Okay, we have everything on right now. So it's producing 30 volts with 1 amp. Okay, so in terms of consumption we have around 500 milliamps, sorry, around that. We have 480 in the GVDA, and let's increase here to 2 amps. So 2 amps is with 0.640 somewhere there amps, and sorry, milliamps, and the GVDA it's more stable and it's okay, all right, in the 620 to 30 milliamps also, so it seems to be good. Let's continue. 3 amps. At 3 amps we have a consumption from the household line of the 0.900 and like 1 amp almost. Yeah, and also in the 950 milliamps to 900 and something near 1 amp here in the 268B. Okay, seems fairly good. Let's move to 4 amps. Okay, I have to start this. 4 amps, 30 volts. So we have here in the power supply that is consuming 3.972. We have 1.4 more or less amps, and also on the GVDA 1.38, so it's more or less the same. Okay, and finally 5 amps. Let's see what we have. 1.78, 1.75, something like that, and that is exactly what GVDA shows, and this one is oscillating a bit, but is also pretty near the same values. Okay, very nice. Let's continue. So now let's talk about a bit about the leakage detection feature of this device. If you use a normal clamp meter like this one, and this one is a pretty good one, you can take the wire inside the clamp and you will see that it will not show anything because the positive cancel the negative, so the current reading will be 0. If you take this, let me just 0 it, yeah, and you put in here, you will have the leakage value. So this clamp meter is able to show you the value in milliamps of leakage of this wire, and this is the difference between the values registered while you measure the positive or the live and the values that you have. Oops, sorry, I took this out of the correct, and the values you have not DC, and the values you have while using it, while measuring the negative or the neutral. So this is the way this clamp measures the leakage. Yeah, as you can see, again we have 1.8. Let me see. Yeah, it's again we have between 1.8 and 2.0, I think. Yeah, the leakage on this device. So this is in terms of AC, but you can do it also in DC. This is outputting right now 30 volts, I believe. Yeah, 30 volts with 1 amp. If you measure, let me put this in DC. For DC we have to 0 it. Okay, so we have 1 amp 52. It's more or less that the power supply is showing, and now the fan of the power supply turn on. I hope that it will not ruin the sound, and we have 1.67 in terms of the live wire. So if you measure both, it will give you the value of leakage. Okay, so this is right now negative because I'm measuring in the direction that, let's change it. Oops. Yeah, right now we have the correct screen, and let's try it like this. I think I have to 0 it again. Yeah, let's try again. 1.50 something and 1.45. So the difference between the two, it will be something like yeah, 15 milliamps, around that. Okay, so that's the leakage feature or leakage detection feature of this device. Now I will test the resistance. This is my precision resistor reference board. It also has capacitors, so capacitance also. So it has the values in this white zone that was registered in the factory for reference, and that's what we are using for testing the accuracy of this board. So again, let's start the resistors. Let's start with the first one. This is in auto mode right now, so we have 10 ohms, okay, 10.2, not bad, 100.03 ohms, 100.6, okay, 7 here, we have 1.0003K, so this will not show for sure because of the resolution, but we have 1.002, not bad at all, and then 9.995K. Okay, 9.98, well, also close, and the last one, it's 100, let me see, 100.06, 100, rounded, yeah, 100, very near also. Now it's the time to see the capacitance. We have 102 picofarads. Let's see if we can detect. Not feeling it. Okay, moving on. 1.02 nanofarads. 999, yeah, it's almost there. Not quite. 10.4, I think. Let me see. 10.4. Yeah. 10.59, so 10.6, a little over. And we have 98.7 nanofarads, 101.2, and we have 929 nanofarads. This gives always some weird results. I bought two new boards. Let's see what value we have in here. 952 nanofarads. Okay, much better. Even so, we are having micro. Yeah, but anyway, it's it's a decimal, so 917.20. So it's near this one. This always gives me weird values, so I believe that this marking it's not okay. Let's bring another one for testing to make sure that we are seeing a correct result. So this one is 981 nanofarads. Okay, still a bit below. And the last one is 10.0 microfarads. Let's see what we have in here. 10.51. Okay, let's see this one. 10.40, 10.55. It says 9.80. Let's see this one. 10.0 also. Sometimes I don't know if the guys are telling the truth or not. 10.75. Okay, that's it in terms of capacitance. So for continuity, here we have it. It's on the position. Let's try to see how fast it is. Well, it's not the fastest in the bunch. Yeah, you can see that the sound here has the delay. It's pretty fast to update the screen, but in terms of sound and light, because it has a light, yeah, it's not the fastest one. Even so, you can work with him fairly well, but not the fastest one. In terms of sound, the screen updates very quickly. Yeah, that's it. So let's test some diodes. Let's start with this one. Okay, it has, yeah, 0.604. I think normally it's about 690 something, but it should be okay. Okay, now a LED, 1.732, it's correct, and this one it's the same voltage, I believe. Yeah, and this one it's 2.4 0.7, something like that. You can see that the light turns on, and it shouldn't work on the reverse, yeah, like this. So seems okay. So for frequency measurement, I brought my function generator to the bench. I'm using a XDG2100 from Owen. This is a 100 megahertz function generator. So what I will do now is create some signs to see if it detects the frequency. I'm using a 5 volts VPP signal, and let's start with 1 hertz. It is supposed to go up to 10 megahertz in terms of frequency detection. So let's see it. In terms of 1 megahertz, in terms of hertz, we have 1 hertz. It detects with 2 halves to 2 counts less. Let's go lower to see where we can go. It takes a while below 1 hertz to detect, but it gets there. 100, 700 microhertz. We are now in microhertz. We can go up to 600 microhertz. Let's see, 500. It takes a while to get there. 500 microhertz. 400. Yeah, 400. It is not able to go there. 500. It's the minimum that we can go. Okay, so let's start increasing this, like 10 hertz. Okay, spot on. 100 hertz. Okay, still very good. 1 kilohertz. Nice. 100 kilohertz. Okay, pretty accurate. Let's go to 1 megahertz. Okay, it's 2 counts below. Let's increase this manually. So 2 megahertz, 3, 4, okay, 5, 6, 7. It seems it's gaining counts as we go up. 8, 9, and the maximum 10 megahertz. I believe this is okay because it does not have enough digits to go further. 11 megahertz. The maximum that we have in here, I think it's 10 megahertz. Let me see what we have. Yeah, the user manual refers to 10 megahertz range. Let's see. Up to we get an accurate. Okay, let's do 15 megahertz. 20. 25 megahertz. So this is the range. 30. 40. I think the maximum is 30 megahertz. Yeah. After that, it will start giving you bad results. So this can detect frequencies up to 30 megahertz. Okay, nice. To measure the current, I will start by setting my mini-wire soldering iron to 150 degrees Celsius, and then using this thermometer, I will see what is the temperature that the tip is. Let me see. I think this is a little bit hard. Let's try to do it again. Okay, 130, 132. So this is a bit off by 70 degrees from the temperature that it says here. I don't trust much on this temperature reading device, But anyway, that's what we get. Okay, now let's bring GD166B to double check. Let me take it like this. And let's try to have the temperature reading. Okay, it's going there. 75, it should be in 100 in a second. It's a bit slower than the other two, but it's getting there. So we are at 116, 118, almost there. This one is a bit slower than the other two. Let's see what temperature it will read. So it's reading 120 degrees. Okay, that's enough. Now let's bring the 268B and let's see what we have in terms of readings. Okay, it's a bit faster. And is also reading about 116, 18, 120. Okay. 121. So this is more or less the temperature we had with the GVDA 166B. So let's again try with the thermometer because it gave a temperature higher. But at least we have some good news and some bad news. The good news is that the 268B from WinAPEX seems to have a very nice temperature reading. The bad news is that both this thermometer and the Miniware soldering iron are not accurate. So yeah, this is off by 30 degrees Celsius and the iron for about 30 degrees Celsius. That's quite concerning, to be honest, because this should be accurate. Okay, but it's tested what we wanted. It seems that this WinAPEX is accurate while reading the values. It gave exactly the same temperature I got in the GVDA. Let's wrap this up by starting with the price that you can find in AliExpress at 29 euros or around $32. And it is pretty much in line with other devices in the market for the same goal. This is a smart clamp multimeter and in general all the measurements were fairly accurate and within the specified error margins in the user manual. So a good point for that. The leakage detection in this device is a differentiating factor and can be very handy to track problems in your electrical installation that cannot be found normally by usual clamp meters. The small size is welcome and it fits very well in your hand, and even with the small size, the clamp can open 2.6 centimeters, more or less the average in this kind of devices. There is something that I would like to see corrected, and that is the lack of battery power indicator in this device. For a USB charge device, the lack of battery indicator can be a serious bummer, so there is room for improvement here. Even so, the experience with this device was pretty positive, and if you are looking for a clamp meter with leakage detection, this is a very good option. If you also think so and are considering to buy one, you can always use the AliExpress or Amazon affiliate access links in the screen or in the description to sponsor the channel without paying a cent more for your purchases. Thank you for your collaboration. And remember that if this video was in any way useful to you, you can help me to spread the love by slapping that like button. And let me tell you that if you aren't yet subscribed, you may be missing a lot of new gear that comes to the market, since every week I receive new equipment to review. That's all for today. Thank you for watching this video, and I hope to see you in my next one.